Hi everybody. Today we will start the third module for the R planner. Before we start, I would like to go a little bit backwards. There are some questions that the trainees are asking. So I will try to answer those questions before we will proceed to the third module. So what I'm going to do, this is a question asked by one of the members. The question, what parameters on LBC we need to enter and what does it calculate for point-to-point or point-to-multipoint? So as I discussed and I repeated many times, the R planner is based on, of course, on the product. So if I open again the LBC, which is a major tool which we rely on when we start to do planning, then we will go to the R planner to do the same with the R planner tool, which is much more sophisticated. But the link budget calculator gives you the first indication whether to go or not go, or how to do the implementation of the planning. So the first thing when I discuss about parameters is the product. Which product? Is it point-to-point, point-to-multipoint? And then the R planner will give you the catalog, the exact catalog, which we need to be taken into consideration. So the first thing is the product. The product that need to be used, the regulation, the frequency, and the product. The next is the frequency regulation, whether there is ETSI regulation that limits the EIRP or other regulation, FTC, that limit the TX power. Then we need to choose which channel bandwidth we are going to work with. If it's in interfered environment, then maybe I will consider a much lower narrow channel bandwidth than a large channel bandwidth. Remember that the more you're exposed to interference, the more your channel bandwidth is larger, you're more exposed to interference. The next is the dual MIMO. All RADWIN, before we go to dual MIMO, all RADWIN products are dynamic channel bandwidth. Of course, you can move between different channels, and the algorithm is automatically, it's called dynamic channel bandwidth on the uplink or downlink per subscriber in the point-to-multipoint, which is a huge advantage when you are deploying a point-to-point or point-to-multipoint in interfered environment. The next parameter is the dual MIMO. Of course, the dual MIMO is automatic decision. Remember that MIMO is multiple in, multiple out, where you are transmitting in two streams. Different information on different polarization. Then you can increase and double your capacity. The next parameter is the fade margin threshold that you want to achieve. And we'll discuss it. If it is about lakes or above lakes on water, then I expect more fade margin to secure my signal, to secure my link in case of deterioration of the performance. The other parameter is, of course, the antenna gain. Which antenna gain we are going to invest? Is it embedded 16 dBi? Is it integrated 22 or 23 dBi or the external antenna for much longer distance. The modulation are based and taken from the sensitivity table and carrier to interference tables that are part of the RADWIN product. And when you are planning radio planning, and the radio planning tools rely on those sensitivity tables and take it into consideration when you are planning radio planning. The TX power can be adjusted according to interference, and sometimes you need to reduce the TX power in order to achieve less interference. The climate factor also need to be consideration because some links are deployed in humidity or rainy environment, and this also can interfere with the performance of the link. The benchmark that I gave you, required availability is 4 nines, required thread margin is between 10 and 20 dB, and RSS is between -45 to -65. Actually, we looked at it before. The main difference between point-to-point, point-to-point, and point-to-multipoint is the need to allocate resources, what we call committed information rate on the uplink and the downlink for each subscriber in a point-to-multipoint deployment. I explained about the difference between SLA customer and best effort customer, but this is the main difference. When I discuss about point-to-multipoint, I always ask what is 1% of in terms of capacity. 1% can be 1 megabit per second, or 1% can be 3 megabit per second. It depends on your calculation and the link budget calculator per each subscriber unit, the distance, the RSS that you can get, and the modulation that can be achieved for each one of your subscribers. Now, I have many questions regarding synchronization. And synchronization, I agree, it's very important when you are doing the planning. But let's go back. I opened the radio planning, the same radio planning that we looked at it yesterday. Actually, it's a safe city, smart city solution. And you can see that I turned on the radio parameter that related to hub site thing. It's the synchronization. Now, if I go back to project setting, you can see that at the bottom, there is HSS and GSU. Now, the decision whether to use GSU or synchronization over Ethernet, it depends on the synchronization method that we want to adopt. Now, if it is a JET or JET Duo point-to-multipoint beamforming antenna, the GPS is integrated. So if it is a point-to-multipoint deployment, definitely I will use the GSU as the main source of our synchronization. Because it's already there, we just need to enable the hub site sync, and that's it. We are synchronized for all the sites, inter and intra synchronization, just to enable the GPS synchronization. Now, in a mixed configuration where there is point to multi-point, point to multi-point, point to point, we need to consider external GPS. It's called the GSU unit, where you need to synchronize the entire network with the external GSU. But if it is one tower or two tower, and the distance is far away, 5 kilometers or 6 kilometers, then I definitely use the synchronization over Ethernet. It means that there is one main master clock, which is the ODU, can be the jet point to multi-point, it can be the D+, it can be the C, it can be ODU that is the master clock, and this master clock provides the clock to the other clients, to the other ODU on the same tower. And it's enough. If there is a need for inter-synchronization, I will put a GSU, and the synchronization is over Ethernet. So next week, the next webinar is describe exactly how to synchronize inter and inter-site. And of course, the R planner is taking all these conditions into consideration when we are doing the planning. I open the plan, I turn on the parameter that's related to the hub siting, and you can see that there must be one master clock in every deployment, in every tower. If it is GPS, then the GPS becomes the master, and it's clear that the other will be client. C means client. INU means independent. It means that the jet in this position is the master clock, and it provides the clock to the other device. Now, because of distance, and if I turn on the declaimer, distance, you can see that there is a 6 kilometers. Now, this is a mixed environment of point-to-point and point-to-multipoint. So I expect to put GSU here, and GSU here to synchronize the point-to-point and the point-to-multipoint on that tower. There must be synchronization. Now, if I look, and now we are starting the third module, if I generate the report, the BOM, let's look at the BOM. You can see that there is 5 GSUs required to synchronize this plan. It's a mixture of point-to-point, point-to-multipoint. That is why I put GSU. Now, when you go back to the setting, it's definitely need to be GSU and not synchronization over Ethernet, because it is a mixture of point-to-point and point-to-multipoint. So you cannot avoid GPS, external GPS, on each junction that carries point-to-point and point-to-multipoint, or a cascade or chain of point-to-point links, like in this position here. There was a point-to-point links which are connected to each other, so probably I need to synchronize with the GPS. Now, if you want to avoid GPS, because GPS costs money, you can, but we need to consider it very carefully, how to avoid. Maybe physical separation can be need to be taken into consideration to avoid external synchronization when GSU is required. So I hope I answered those questions. Next week we will have a session for how to synchronize RADWIN equipment. Remember, synchronization is mostly required to avoid collocated interference. Now, if there is other third party on the same tower or transmitting nearby, we cannot synchronize RADWIN equipment with ubiquity equipment, or with Cambium equipment, or with other vendor. We can take care of our synchronization to avoid self-interference. But in case there are other vendor transmitting on the same tower, it is avoidable to be interfered. What we can do is to perform physical separation, 3 meter, 2 meter. Then the other transmitting devices which are not synchronized to us. So I will start now to discuss the RADWIN tool, and we will discuss about line of sight coverage, assigning frequency, calculating services and troubleshooting, RADWIN radio layers, generating the bomb, and generating the report. The output of any R planner must end with the bill of material for each site, the report that carries all the parameters that require to deploy the link, and to properly configure the link. All the aspects, from antenna tilt, RSS levels, and then when the installer guy technician go to the site, he starts to do the installation, he is doing the wind touch alignment and perform the speed test and the RSS level. The wind touch report is including all the information about the real performance of the link. Now, remember, this is a cloud service where you can always compare real deployment with a planning. And this is the most important. It's correct for point-to-point, it's correct for point-to-multipoint, in the future in TV white space, or in telegraph performance that we are doing and coming very soon. Now, line of sight coverage, it's very important. We discussed about it many times, but now I want to emphasize some issue. Of course, the coverage of antenna, it depends on the radius that you want to achieve from a base station. It depends on the ARP that you are using and regulation limitation. The upline allow you to color the line of sight coverage of every site, coverage radius, graduate color according to MCS, and modulation. It means that the modulations are changed according to distance. It means that the color is changing according to different modulation. HB has height and tilt, remote HCU height, color of line of sight, color of non-line of sight is the dark area that you can see in those areas. The black holes are actually non-line of sight environment, where we can expect topological obstacle that can impact the performance of the link. Now, yesterday somebody asked me about the passes. If you go backwards to the project setting, there is propagation model, free space, suburban line of sight, non-line of sight, and ECC 33. Now, when we are doing the coverage, the R planner is taking into consideration those urban or suburban or rural areas. Of course, that if we are in a rural area, we expect less obstacles, less buildings, but we can expect terrain obstacles. In the urban area and the suburban area, we can expect more buildings that can block the signal and perform a shadow on the RADWIN signal or the transmission. Now there are propagation models which are taken into consideration. We prefer to work in the suburban, which is the most popular and the most common solution for RADWIN. But remember that in different models, there are different aspects of coverage that need to be taken into consideration. In the rural areas, we can expect more vegetation. In the urban and the suburban area, we can expect buildings. And there are propagation models for each kind of scenario where the R planner taking into consideration where it's doing the calculation. Now, if you look at on the right left, I have here a small cell backhauling project where we can have a 3D map which can be attached to the R planner, and we can do calculation in three dimensions. It takes into consideration reflections and diffraction from different objects in the urban area. We have this possibility, but those maps cost money, and somebody needs to pay for this in order to get urban or suburban calculation on the cover. In the past, we had this possibility. It was common, but the map cost money, and I'm not sure that everyone can pay this money. By the way, it's the environment changed, buildings are coming and changing the view, and the map need to be updated from time to time. It costs money, but it's there. We can do it. Now the new generation of the radio planning takes into consideration different clusters and different heat maps. And this is the new generation, the next generation of the RADWIN WIN. It's called WIN plan. Now, I discussed about the propagation models, and you need to remember that there are different propagation models. The free space take into consideration only the antenna and the distance. ECC 33 is for cellular microwave solution, line of sight model taking into consideration the terrain and the antenna height to have a clear result. The N loss, take into consideration the path loss and calculation of different obstacles. It can be buildings in the urban and the suburban environment. Now, for our planner, I'm using the free space in a suburban, and of course, I'm ignoring 3D or buildings obstacles. And when we are doing when we generate the report, later on I will show you. I save the report, generate. I always open the report and I write this is the report, and later on we will go over it. There is a disclaimer. I always add site survey is mandatory. Remember, the coverage, our coverage is rely on the free space. It doesn't take into consideration line of sight or non-line of sight because of building. That is why I always recommend on-site survey is mandatory. And by the way, if there is a line of sight or non-line of sight, you will see it during the spectrum view. When you are doing a spectrum view, you will see definitely that one of the polarization is shadowed. And the RSS level in one polarization, it can be on the vertical or on the horizontal, is shadowed. It means that there can be obstacles. It can be some object that shadows the signal. But we are not taking into consideration. That is why I'm recommending to do always site survey. And the algorithm for the propagation of the signal is free space and suburban model. Of course, we are working in the sub-6 frequencies. That is why the free space is more suitable to our calculation. So first we need to determine the radius of the coverage. How many subscribers we are asking to cover. It depends on the number of the subscribers. It depends on the capacity of the subscriber and the density of the subscriber. It means that if I have coverages of 3 radius and I have too much subscriber, more than 64, maybe I need to add an additional sector. Maybe I need to use the jet dual carrier, the 5 and 5 on the same sector. And we can coverage, we can get more subscriber per and more capacity and more throughput per a given sector. So if you go to the real, you can see that there is a sector here. Let me turn off the there is a sector. Looking at the coverage, I can see that the coverage is 5 kilometers radius. I can edit this coverage. I can put 3 kilometers. And of course, I can see that those subscribers are out of the coverage. I can take it to 10 kilometers or 40 kilometers. Remember that RADWIN products, point to multi-point, are up to 40 kilometers. Point to point, however, is up to 120 kilometers. And when I discuss it, many ask me, yes, it's 40 kilometers, point to multi-point, and 120 kilometers up to for the point to point. I say yes, but remember, there is always link budget calculator on the background. We can always put theoretically 120 kilometers. It's possible. But of course, you can expect different availability, different throughput. It depends on the requirement that you want to achieve. I can tell you that honestly, the longer distance that I did in point to point is above 100 kilometers. Many times I need to split the 100 kilometers to 2 or 50 kilometers, but you can achieve a very nice throughput. And you can see that probably in long distance, you can have obstacles of terrain, obstacles, topological obstacles. Let's say if I have entity here, you can see that the coverage is impossible. Probably when you are taking point to multi-point to long distance, it will not be able to implement because of the topological or probability of topological. Now, so the dark areas are non-line of sight. I don't see buildings. I need to do site survey. And the coverage area need to be carefully examined according to calculation of capacity, throughput, density of subscribers, and so on. What is the throughput they want to achieve, and the antenna gain. I know customers that are using the 16 dBi up to 5 kilometers. But of course, when you are taking 16 dBi antenna to 5 kilometers, it's possible, but you are losing CIR and you are losing resources from your sector. And the sector becomes not efficient. Probably in medium distances, up to 5 kilometers, I will use the turbo gain or the 22 dBi antenna. And then I can achieve better performance, better availability in 4 kilometers. Let's bring back the coverage to a reasonable coverage, and let's put it in 5 kilometers. So remember that the color means that you have non-line of sight, or the distribution of modulation along the distance. So we can add coverage or list the current coverage. And we can display the line of sight coverage. Now, you can play with the coverage, give you a nice ideas. For example, I can list current, I can hide the coverage, I can show the coverage, and I can play with the coverage according to different simulation that I can do. For example, many ask me why you have a base station here, you have a sector here. Why not to add a base station here? For example, like this. I will add a base station. I'll put it in 5.4 universal. Let's put a base station here and try to get the coverage from the other side. Now, the frequency reuse is frequency reuse 2, so I can use two frequencies, 5.4 and 5.7, to implement the entire solution. If it is a jet duo, then the jet duo can cover the same sector with two different frequencies. Now, many ask me why I cannot do something like this. So let's put different color. And I will hide the yellow. So now what I did, I created a new sector. I colored it in red color, and I did the coverage from different angles. And at the same time, I disabled or hid the yellow sector. Now, a big question. If I have a point to multi-point here, why I cannot do a point to point here? Why not I can do a point to point here? Now it gives me the possibilities of the base station. I will choose base station 3, and I will try to make a link from the other angle. Remember, I can choose whatever I like. It's good, so why not? I add the resources, depend on the uplink downlink, and I have a link. Let's take it a little bit. So we have a link. Now the question is there is sufficient capacity in 20 megahertz to support this subscriber from this area? And I believe it's possible. I believe it's possible, and so we have two options. One, to connect this subscriber to this base station, either to connect this subscriber to the other base station on the. And this is the idea of different coverage and different radius of coverages from different point of view. And this is something that you need to be able to do, and it gives you the flexibility to think whether you can have better performance from different coverage. Now, remember that RADWIN has the capability to work with frequency reuse 2. Frequency reuse 2 means that you can put back-to-back jet beamforming and to work with a frequency reuse too. F1, F1, F2, F2. This is the idea of a frequency reuse too. Since the beamforming antenna is so narrow, we can afford ourselves to work in a frequency reuse too. Remember that RADWIN come to release to the market the second generation of the beamforming. It has a better performance than the first generation. It has narrower side lobes and back lobes. So the intention is in the future to come with a frequency reuse one solution where entire deployment can be implemented with one frequency. So currently we are in frequency reuse 2, and unlike other vendors that I'm not going to mention the names, we have a real beamforming and not spread or distributed beamforming. Our beamforming is unique. It's a one beamforming. It's a one narrow beamforming. When I discuss next week about RADWIN interference methodology, I will explain about this beamforming, how it's done, and how it's capable to provide you better interference mitigation than any other vendor that claim to have beamforming, but they are using filters on the uplink or filter on the downlink, and at the end you will not get the same performance that you are asking for. So assigning frequency is very important. That is why when I do the coverage, I color the sector. Here it's not, we have, for example, sector 1 is turning to the east and sector 2 to the west. So it's F1 and F2. But if there is a back-to-back like this situation, let's close this and open a new plan. So we have the red sector and the blue sector. And remember, there is a beamforming, 90 degrees beamforming, continue to scan here, and 90 degrees beamforming, continue to scan here. So the blue color is F1 and the red color is F2. Now, we have the given frequencies for each deployment and the channel band. So we can define the frequency here, or you can leave it free and let the R planner to do the planning for you. If it is a 4 sector, then it's easy. I have 4 sectors. I can definitely decide that this will be F1, this one F1, F2, F2. Now, if you have an entire sector, let's say that I have here another side, let's call it side B. I will add another side. I will add another base station. I will leave the frequency empty. And I will create a new sector. So what do you think? It should be a blue color or a red color? So I can do F1, F1, F2, F2, and So it can be F1, F1, F2, F2, F2. So F2 can be nearby to F1 because we can afford ourselves to do it and to do the implementation according to the frequency allocation. Now, when you are doing the planning, the R planner will do this allocation for you according to the antenna limitation and the antenna capability. In this scenario, it is advantage that we can implement in one frequency or two frequencies the entire deployment. So this is the idea of the frequency allocation, which you can leave the frequency allocation empty. Sorry. You can leave it empty, or you can decide which frequency to use. If I use the frequency, then I can see the channels. But if I'm leaving it empty, at the end, the algorithm will complete this deployment according to the plan you did. Let me start to look. I will close this session and let me open another deployment that I did. Anyway, let me open it again. Okay, before I will go, let me open the same. Okay, because we are discussing about frequencies, I want to show you a little bit the proper possibility of frequency and how to calculate the frequency. So what I'm going to do is to open a slide. Actually, this slide describes the beamforming antenna, and it's something that so the beamforming antenna is a narrow beam. It's capable to scan in 90 degrees and provide us the frequency we used to. It's a real beamforming. Now, in a jet duo, we have two kinds of beamforming on the same sector that are doing the same scanning. Now, this provides RADWIN to cope with interfering when we are doing frequency reuse too. This is the actual beamforming antenna that we are using when we are deploying our solution. The jet platform capable to do the frequency reuse F1, F1, F2, F2. Now, in a full deployment, we can do F1, F1, F2, F2, F2. That's why when I'm doing the planning, I come to the planning, I need to consider this advantage. So, if I have a sector here, I can define the frequencies for each sector. And then, if I have a full deployment, I need to consider the same frequency reuse that I have here. F1, F1, F2, F2, F2. And the same, the other deployment for collocated and adjacent channels in the frequency. Now, the R planner can do this for you. It can provide you the frequency allocation according to the band that you have. So under the tools, there is a button. It's called frequency, assign a frequency. So if there is a blank and you didn't do the frequency reuse by yourself, the algorithm will do it for you. Assign frequency, it will start to calculate the frequencies, and at the end, it will put the right frequency that you are desire according to the plan that you are doing. So when frequencies are assigned, it takes into consideration the beamforming antenna, the ability to do frequency reuse, and it will spread the frequencies according to the limitation and the technical specification of the antenna. Now, it is a huge advantage when you are doing a large deployment in large environment coverage. So remember that you have the radio planning tool, the frequency assignment. You can do the frequency assignment, which is based on RADWIN technology. Now, if it is a dual carrier and there are two beamforming on the same sector, it will continue to calculate 5.x or 3.x or 5 and 5 on the same sector. In a large deployment, it is an advantage. Now, I showed you many times that you can look at the properties of the link, and the property of the link give you the link budget calculator, the performance of the link, the RSS that you can get, the channel bandwidth and the throughput that you can get according to the link budget calculator, and this is another option that you can do. Rather press on the link budget summary or go to the properties to see the link budget calculator for each link that you did the planning. Now, if the link is red and there is a problem, for example, let's create a problem. You can see that let's go under the coffee. Let's look at this. If the links have let's open another plan. Now, I have two links. They are parallel in point to point. And one of them is green, the other is red. Now you need to start and do the troubleshooting to understand what is the reason that one link is green and the other is red. Now, there's possibility they are interfering each other because they are so close, they are on the same towers, and there's no synchronization between them. So synchronization can be the first thing that I need to think about. Remember, in every tower, there must be one master clock and the other is red. But still, there is a problem. One is green and the other is red, on the same direction, the same distance. And now we need to start and troubleshoot the link. If I do a right click on one of the links, I can see that there is availability problem here. And probably this is the only thing that we need to consider. Now, let's delete this link and let's take the other from the same point. Remember that one of them needs to be the master clock. Now, both of them are green. And in this position, I will add a clock. There is a master clock. And the other is and one of them is the master. Now, if there is an obstacle or a line of sight or synchronization problem, you will see that the link become red and there is error. Now, how to fix a link calculation error? Global action, make sure you use the channel bandwidth you need. For example, if you only require 15 megabits per second per sector, there's no need to use 40 megahertz. Interfered link, improve C2I by increasing TX power, check synchronization. If needed, add height, separation of 3 or 5 meters, or interfered link. Now, many times asking me how to simulate interference. And when you are reducing the TX power, it's not a real simulation of interference. When you are trying to simulate interference, the best way is to add another device or another audio nearby on the same tower or the same area, which are transmitting towards or nearby the same audio that you are using. To troubleshoot problematic link in RAD, you need to edit link's property to find out reduce TX power due to strong interference signal, since the service we are planned for not be obtained. Edit the TX signals of the interfering signal. Of course, interference can be reduced by proper synchronization, by proper TX power, but if you want to simulate interference, you need to add additional audio which is transmitting nearby to perform the interference. So when you are having a link which is RADWIN, you need to start to troubleshoot the link. It can be because of capacity, it can be because of profile, it can be because of lack of synchronization, and it can be because of TX power and interference. There is interference button where you need to press the interference and to look on the mutual interference that you can expect from each kind of entity in your plan. And of course, if the profile, the TX power, and the interference details. All these can cause to the deterioration of the performance and the link become red. The tool gives you the indications where to look for the problem and to do the troubleshooting. We discussed about RADWIN radio layer. When you press on the button, you can see the HSS, hub state sync, you can see the TX power, you can see the availability, you can see the channel, the height, the RSS level, the channel bandwidth. All this can be indicated by the radio layer. So of course, the most important checkbox is the synchronization to verify that you are well synchronized. Now, the output, the three output, major output of the radio planning is the report, the KMZ file, and the BOM. The BOM is the material that are used for doing the planning. It can be only those products that used by the catalog to generate the report, or you can add and edit additional products like cables, like POEs, like IDOH, according to what you need to do the deployment of the site. So this is the BOM. It's actually the quantities that you're required to do the planning and to do the deployment. It also asks you if you want to save. And regenerate the BOM. If I press no, it will generate the BOM according to the plan only. If I press yes, it will take all the required and necessary accessories to do the planning and deployment, the physical deployment. The latest and the most important is to generate the report. If I open the report and I did the generation, I go over it. This is a safe city planning, and I always add a disclaimer that's saying that site survey is mandatory. Remember, the R planner is a survey, it's a planning. And later on, when the installer or system integrator is going to the site, we need to implement those sites. Looking for the transmission, looking at the power, if there is enough transmission point connections, if there is enough power, lightning protectors, POEs, grounding, all this stuff need to be taken into consideration in the BOM. And this is the report. The report contains, if you go from, again, it contains all the aspects for deploying the site. The altitude, the coordinates, the site names, from point to point, point to multi-point, all the bill of material that's required to do the planning. And you can see GSU is here, base stations, post point-to-point links, and all the calculation and the link budget calculator for all point-to-point link, the summary, the distance, the service, and the same for point-to-point. Now, if you go, it will show you the height of the antenna, the tilt of the antenna, the rates that are predicted, the TX power, the EIRP, the RSSI, the fade margin, all the parameters that we discussed before. And this is point-to-point, point-to-multi-point. Step by step, you will get all the information that's required to do the deployment and the installation. And later on, you can compare the real deployment with the planning. If there is a gap between the planning and the real performance, you need to go backward to the planning, compare what the installer did when he did the deployment, and to understand what is the reason for the gap. Good plan, efficient plan, when it works and deployed correctly, it's cost save money, and good efficient plan makes the difference. Not only the product, The product is there. We are coming with a sophisticated product, beamforming antenna, mitigation of interference because of many algorithms that we have on the background working for us. We have a very sophisticated tool to do the plan. So use it. And this is my main recommendation. Good plan, save money and save cost. If you are using the jet dual carrier, which provide you two beamforming on the same sector, maybe you can reduce the number of sectors that you are deploying, the number of base stations that you are deploying. So you can save money, you save cost. And good plan makes happy customer. I would like to thank you for this listening. Next week we have another webinar regarding the air interface and RADWIN methodology, how to cope with interference mitigation. I will discuss again about our all the algorithms that we have, the beamforming antenna, the other technology that we have, technique that we have to cope and mitigate interference. It is related to the unique air interface of RADWIN. Thank you, Eldad, for answering the question. I would like to thank you for these 3 sessions, and I hope to see you face to face very soon after the coronavirus is gone. Thank you for your time. Be safe and nice weekend.
Goodbye all. It was very good to have you. Bye-bye.